Hello, everybody. In today's lesson, we're going to be covering lesson 2.2, the least common multiple in the sixth grade Go Math textbook. We're on page 37. Our essential question that you should be able to answer at the end of this lesson is how do you find and use the least common multiple of two numbers? And so we're going to start with the explore activity. So finding the least common multiple. So a multiple of a number is the product of the number and another number. For example, 9 is a multiple of the number 3. The least common multiple of two or more numbers is the least number other than 0 that is a multiple of all the other numbers. Okay. So in this activity, Ned is training for a biathlon. He will swim every 6th day and bicycle every 8th day. On what days will he both swim and bicycle? So basically, this question is asking us to find the multiples of 6 and 8. So in the chart below, shade each day that Ned will swim. So it says he'll swim every 6th day. So 6, 12, 18, 24, so on, right? Okay. So those are the multiples of 6. And then circle the days that he'll bicycle. And he's going to bicycle every 8th day. So 8, 16, 24, 32, 40, 48, 56, 64, 72, 80, 88, 96. Okay, and so on what days will he both swim and bicycle? So those are the days where we've shaded and circled both of them. Okay, so the first time we circled and shaded both was the 24th. And then the next one was the 48th day. And then the 72nd day, and finally the 96th day. So the number of days that Ned will swim and bicycle are common multiples of 6 and 8. So what does the least common multiple represent in this situation? Well, it represents the days that he'll both swim and bicycle. All right, let's go on to page 38. All right, so how do we apply the least common multiple? So we can use the least common multiple of two whole numbers to solve problems. So look at this example. A store is holding a promotion. Every third customer receives a free keychain. Every fourth customer receives a free magnet. Which customer will be the first to receive both a keychain and a magnet? So we're being asked to find the least common multiple of 3 and 4. So we can do it like this. Multiples of 3. 3, 6, 9, 12, 15, 18, 21, 24, 27, so on, right? And multiples of 4, 4, 8, 12, 16, 20, 24, 28, 32, 36. Okay. Simple as that. Circle anything in common to both numbers. And so the least common multiples of, find the least common multiple of 3 and 4. And we know that it's 12. So the first customer to get both the keychain and a magnet is the 12th customer. All right, so find the least common multiple of 4 and 9 by listing the multiples. So what's the first multiples of 4? Well, we already have got those right there, right? We're just skip counting by fours. Multiples of 9. Okay. All right, so what's in common to both these numbers? 36 is in common to both. And that's it, right? So 36. All right, so let's do a problem like example 1. So every 9th visit to a restaurant, you receive a free beverage. After every 12th visit, you'll get a free appetizer. If you visit the restaurant 100 times, on which visits will you receive a free beverage and a free appetizer? At which visit will you first receive a free beverage and appetizer? Okay, so we're being asked to find the least common multiple or all the common multiples of 12 and 9. Okay, so 9, we just did that up in the previous problem. Okay, and I went out to 99 because it says visit 100 times. Okay, 12, 24, 36, 48, 60, 62, 84, 96. Okay. All right, let's circle factors that are in common. 9's not in common, 18's not in common, 27's not, 36 is. 45 is not, 54 is not, 63 is not, 72 is. Okay, so just 36 and 72. The first time will occur on the 36th visit. So do two whole numbers always have a least common multiple? Yeah, they have to. Okay. Okay, because the product of any two numbers is a common multiple. If we said 3 times 9, we know that a multiple of 3 and 9 is 27. And then if there are no multiples smaller than that, then that's the least common multiple as well. Or the product is the least common multiple. Right, so again, yes, the product of any two numbers is a common multiple of the two numbers. If there are no lesser common multiples, then the product is the LCM. We could look at, like, say, the prime numbers 3 and 5. Okay, when we multiply those two together, we get 15. Well, there are no multiples smaller than 15 that 3 and 5 have in common. All right, let's look at page 39. So we have to find the least common multiple of 8 and 56. So you might want to get a piece of scratch paper for this so we can list out the multiples easier. All right, so 8 and 56. So 8, 16, 24, 32, 40, 48, 56, 64, 72. Well, I noticed that the smallest multiple of 56 is 56, right? Well, we already know that 56 is a multiple of 8. So we already know that the least common multiple has to be 56. Okay, so there's no reason to list out all the multiples of 56 if we already know that the smallest multiple of 56 is 56, and that 8 is a multiple, or 56 is a multiple of 8. All right, so let's look at 25 and 50. Okay, again, 25, 50. Do I need to go any further? No, because the first multiple of 50 is 50. So the least common multiple is 50. 12 and 30. All right, let's start with the smaller number, 12, 24, 36, 48, 60. Now I'm going to stop there because I know that if I double 30, that's 60. So 30, 60. So the least common multiple is 60. 6 and 10. 6, 12, 18, 24, 30. We can stop there because I know that multiples of 10 have to end in a 0, right? 10, 20, 30, 40, 50, they all end in zeros. So as soon as I got to a multiple of 6 that was 30, or that ended in a 0, I can go ahead and list the multiples of 10. And we know that the least common multiple of 6 and 10 is 30. All right, 16 and 24. So 16 plus 16 is 32. 32 plus 16 is 48. 48 plus 16 is 64. 64 plus 16 is 80. And then 96. Let's see, 24. 24 plus 24 is 48. Do I need to go any further? No, 48 is in common. It's the smallest multiple that is in common. Okay, number 8, 14 and 21. Okay, 14 plus 14 is 28. 28 plus 14 is 42. And I know that if I double 21, that's also 42. So 21 plus 21 is 42. So the least common multiple is 42. 9 and 15. 9, 18, 27, 36, 45, 54, 63, 72, 81, 90. I'll go ahead and list them out to 9. All right, 15. 15 plus 15 is 30. 30 plus 15 is 45, and I'm going to stop there. because I see that 45 is in common to both numbers. Okay, number 10, 5 and 11. All right, now I notice that both of these numbers are prime. So the smallest common multiple has to be the product of those two numbers. So 5 times 11 is 55. But let's just prove that it's 55. So 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60. Well, go ahead and stop there. 11, 22, 33, 44, 55. So I can stop there, right? We see that 55 is in common to both numbers. So if both numbers are prime, all you have to do is multiply them together to find the least common multiple. All right, 11. During February, Kevin will water his ivy every third day and water his cactus every fifth day. On which date will Kevin first water both plants? So again, we're asking to find the common multiples of 3 and 5. 3 is prime and 5 is prime. I know the least common multiple of those two has to be 15. So he's going to water both plants on February 15th. Let's go ahead and prove it. 3, 6, 9, 12, 15. I know 5 can become 15. 5, 10, 15. Okay. When will Kevin water both plants again in February and explain? All right, so I know the next multiple is going to be a multiple of 15 in this case, because the smallest number in common is 15, so the next number in common will be 30. Well, he's not going to water the plants again then in February. Okay, and because we're talking about February, we know that there's not 30 days in February. All right, number 12. Given any two numbers, which is greater, the least common multiple of the numbers or the greatest common factor of the numbers, and why? Well, the least common multiple will be greater. Okay, so I'm just going to write LCM as the answer. Okay, so the least common multiple is a multiple of both numbers. So it is greater to or equal to the greater number. So like when we looked at 3 and 5, the least common multiple is 15. So it's greater than the largest number, 5. The GCF is a factor of both numbers. So it has to be less or equal to the smaller number. For instance, so let's look at 3 and 5 specifically. Okay, so 3, 6, 9, 12, 15. 5, 10, 15. So we see that the common multiple of 3 and 5 is 15. So what are the factors of 3 and 5? Well, the only two factors of 3 are 1 and 3, and the only factors of 5 are 1 and 5. So the GCF is 1, which is less than or equal to the smallest number, 3. In the least common multiple of 3 and 5, the least common multiple is 15, which is greater than or equal to the larger number 5. So this, given any two numbers, the LCM will always be greater. All right, 13. The red line and blue line trains arrived at the station. When will they next arrive at the station at the same time? Okay, so we want the red line and the blue line. And they're going to arrive at the station every 8 and 10 minutes. So we need to find the least common multiple of those two. Okay, so 8 and 10. And I know that one of the multiples of 8 has to end in a 0 for it to be in common. So I can stop when I get a number that's a multiple of 8 that ends in 0. 8, 16, 24, 32, 40. Okay, so that ends in a 0. So I know that that is also going to be a multiple of 10. So in 40 minutes, they will arrive at the station again at the same time. All right, how about the blue and yellow lines? Just arrived at the station. When will they next arrive at the station at the same time? So we need to find the least common multiple of 10 and 12. Okay, again, I'm going to start with this one this time because I know that for it to be in common, it has to end in a 0. So 12, 24, 36, 48, 60. So I don't have to go any further than that because I know that 60 will be a multiple of 10. So they'll arrive at the station again in 60 minutes. All right, how about all 3 trains just arrived at the station? When will they next all arrive at the station at the same time? So this time we need to find the least common multiple of 3 numbers. All right, I went out 12 multiples just to see. Okay, so I know that for it to be in common, it has to end, one of the numbers has to end in 0. Okay, so let's see, 10, let's do 12. 12, 24, 36, 48, 60. Okay, but I can't stop here because 60 is not a multiple of 8. Let's keep going. 72, 84, 96, 108, 120. Okay, well, I know 10 can be, 120 is a multiple of 10. Let's see if 120 is a multiple of 8. So 96, 104, 112, 120. Yes. Okay, so it's going to be 120. Okay, so 2 hours or 120 minutes. Okay, again, I did see that 60 was in common to both 10 and 12, but 60 is not a multiple of 8. When we have three things, all three must be in common. All right, page 40, number 16. All right, you buy a lily and an African violet on the same day. You're instructed to water the lily every fourth day and water the violet every seventh day after taking them home. What's the first day on which you will water both plants on the same day? And how can you use this answer to determine each of the next days? Okay, so we're trying to find the least common multiple of 4 and 7. 4, 8, 12, 16, 20, 24, 28. I know 28 is a multiple of 7. So 7, 14, 21, 28. So the first time they're going to water, she's going to water both. You're going to water both the lily and the African violet is on day 28. The next days will also be multiples of 28. So day 28, 56, 84, and so on. Right, 17. What's the least common multiple of two numbers if one number is a multiple of the other? And give an example. So it's going to be the least common multiple will be the greater of the two numbers. Okay, so for example, 8 and 16. The LCM will be 16. Okay, 16 is a multiple of 8, so the least common multiple will be 16. What's the least common multiple of two numbers that have no common factors greater than 1? And give an example. So it's going to be the LCM will be the product of the two numbers. All right, so let's look at something like 4 and 7. Okay. If we look at factors of 4, we see that there's 1, 2, and 4, right? And 7 is just 1 and 7. So the greatest common factor is 1. So when the greatest common factor is 1, we can just multiply them together to find the least common multiple. So for example, 4 and 7 is 28. All right, 19. The least common multiple of two numbers is 60, and one out of the numbers is 7 less than the other number. What are the numbers and justify your answer? All right, so basically we need to look at the factors of 60 here, okay, because 60 is a multiple of each of its factors. So the factors of 60 are, let's write this out here. So we know 1 times 60. We know 2 times 30. 3 times 20. 4 times 15. 5 times 12. 6 times 10. All right, well, and it says one of the numbers is 7 less than the other. Well, if those are the two numbers, that's not a difference of 7. So that's not it. That's not a difference of 7. That's not a difference of 7, nor is that. This is 5 and 12 has a difference of 7. So the factors are 5 and 12. So the least common multiple of 5 and 12 is 60. Okay, so the factors of 5 and 12, they have a difference of 7 and LCM of 60. All right, the last one. Describe how to find the least common multiple of 3 numbers. We did that, right? We're going to list the multiples of all 3 numbers, and then we're going to take the multiple that is common to all 3. All right, so to find the least common multiple of 3 numbers, you're going to list the multiples of each of the numbers and take the least multiple that is common to all 3. So for instance, what have we just said? 2, 4, 6. And I want to find the least common multiple of those 3 numbers. We'll list the multiples of 2. List the multiples of 4. List the multiples of 6. And find the least common multiple of all 3. All right, well, 4 is in common to 2 and 4, but it's not a multiple of 6. 8 is in common to 2 and 4, but is not a multiple of 6. 12 is in common to all 3 numbers. All right, so that's it for how to find and use the least common multiple. So until our next lesson, I will see you soon.